Hello, in today's video we will discuss about shared memory. Again, with respect to that, we are discussing shared memory, stream pipes, passing file descriptors, open server version 1, then we are discussing about client server connection functions. First, shared memory. Shared memory allows two or more processors to share a given region of memory. That means, as we know that shared memory, that is a small amount of the memory has been allocated between the processors. Later onwards, the processors can access that memory for exchanging the data or exchanging the information. So that concept what we can call as a shared memory here. And this is the one of the fastest form of IPC mechanism, that is the interprocess communication, because the data does not need to be copied between the client and server. That means either client is not copying the data or server is not copying the data, because shared memory is synchronizing access to given region among the multiple processes. So I hope you might be getting the point. What do you mean by synchronization? So this synchronization is usually done by semaphore concepts, okay, between the processes. That means as a kind of scheduling, we are allowing one process after that next process to be access a particular memory here. Okay, that is the reason it is so fast. There is no concept like we need to copy the content in client side or server side here. Next, the kernel maintains the structure of the shared memory. I think this is a simple structure has been given here. IPC permission, this is a normal structure. I think already we discussed similar kind of the things with respect to the message queues, and one more is semaphores here. Okay, here the many fields are there. I taken the two here. Last accessed and last created here. This means LPID is nothing but we wanted to know that which is the process last access and which is the process last created this shared memory data structure. And there is a many functions we are using as part of the shared memory. The first function, semaphore get, is used to obtain shared memory identifier. This function we are using to get shared memory identifier. So the function containing the two arguments here, key here, next size, then a flag here. Return value of this function is identifier with respect to the shared memory on successful, then -1 on failure condition here. Here key value is nothing but usually I think there is a one path name has been provided. We discussed beginning here with respect to XSI IPC concept there. Then we are mentioning the size, how much the memory is we require. The flag value is again it is with respect to the whether we need to access a particular memory or not. Next, once this IPC structure is initialized, then some of the fields has been initialized to 0, like a semaphore, shared memory last PID value, shared memory access time, shared memory detach time, all are set to 0 here, and current time is set to the current time of the system here. And next, there is many operations we are performing with respect to the shared memory here. That is performed by one of the function called shared memory control. That is usually we can call as a shared memory CTL function. It is having the three fields, three arguments. Yes, we can go through that. One is identifier. It is usually what we get it from the shared memory get it here. Next command we will discuss shortly. Next, the third one is it is a structure. It is a pointer to the structure here. And once again, the return value of this function is 0 on successful and -1 on error here. Then command values are are there here: IPC stat, IPC set, IPC RM ID, IPC, then semaphore lock, shared memory lock, shared memory unlock here. Here the first one, IPC stat, is nothing but we are fetching the detailed structure of the particular segment, stored it in the structure pointed by the puff. It is already existing one we are fetching here. And second one, we are setting the sum of the fields with respect to the structure, like user ID, permission, yes, and group ID. So these things we are setting with respect to the structure by using IPC set. IPC RMA ID is nothing but we wanted to remove the shared memory segment from the system. Okay. Then lock the shared memory segment in the memory. This means we are not allowing any other process once it start accessing. There is a kind of synchronization. It is, we can assume that. Shared memory unlock. I mean unlocking the shared memory concept means you might be familiar that once we need to lock that particular memory, we need to unlock it here. Then attaching shared memory regions to a particular shared memory what we created so far. With respect to that one, we are using the shared memory attach here. The first argument, that is the identifier. Second one is the address, so in which location you wanted to add. Again, it is a flag value, it is indicating so it is specifying the read or write here. Okay, once again with respect to the flag. Then the return value of this function is that returning the pointer on successful condition, then -1 on error. And this flag value is having some additional values, that is a round here, semaphore round, and it is specified. And with respect to address, we are having the different values here. As specifies address in calling processes. If this value is 0, segment attached to first available address selected by the kernel, means a particular segment what we attached is first available here. Then address is not equal to 0, segment attached to address given by the address if semaphore round is not specified. Okay, that is one more case. Then one more case, the third case, it is also same, but semaphore round is specified here. If the boundary value is specified, that is the lower boundary address is specified. Okay, then in that case it is taking the different values. Then the last, detaching the shared memory regions, that is has been done by the one of the function shared memory dt, that is it is having only one argument, that is address here. The successful condition is returning the 0 value and the -1 on failure conditions here. Next, stream pipes. Stream pipes is just like similar to the previous concept what we discussed here, pipe mechanism. So that is only half duplex, it is a full duplex. We know that half duplex is nothing, only one direction we can flow the data using that pipe at a time. If you wanted to do the bidirectional data flow between parent and child or between two processes, then we can use the stream pipes here. I think a diagram what it shows, just we can make the observation here. FD0 is connected, that may indicate it is this end is acting both read and write, and this is a end is acting both read and write with respect to this stream pipe here. With respect to the stream pipe, the parent uses only FD0 and child uses only FD1, since each end of the stream pipe is full duplex. So the parent reads and writes by using FD0 only. As I already told, using the same end, okay, it can perform read and write operations here. And next, child duplicates FD1 to both standard input and standard output. That is nothing but one end it is taken as a standard input and one end it is taken as a standard output. Usually this concept what we can call as a mechanism. This mechanism what we can call as a filter or also sometimes coprocessor here. Since we can make the observation in the diagram here, the FD0, the parent concerned, it is acting as a read and write both, and this case it is performing read and as well as write here. How it is we can create this stream pipe? By calling the spipe function. Okay, again it is just like file descriptor. We need to pass two values, one is for parent side, one is for the child side. So return value is in the pipe FD only, as we know that already the pipe function we used here. Okay, that is returning the two ends, one is for read and one is for write here. And one more thing we need to understand with respect to the stream pipes is that it is a named pipe also. We can use between the two processes which are belonging to the different parents here. Okay, that is also we can do it here. So some more concepts we'll discuss in the next video.